Hello everyone, I'm Timothy, a non-degree student who is actively studying graduate level mathematics. In this video, I'd like to cover the proof of the Lagrange's theorem. Without further ado, let's begin. Lagrange's theorem. Let G be a finite group and H a subgroup of G, then the order of H divides the order of G. Proof. Step 1. Define left cosets. For any G in G, define the left coset GH equals the set with all elements GH in G where H in H. This implies that every element of G belongs to some coset. Step 2. Every coset has the same size as H. Define a function f from H to GH by f of H equals GH. The function f is injective, since if GH1 equals GH2, multiply G inverse on both sides, we get H1 equals H2. Meanwhile, the function f is also surjective because every GH in GH has a pre-image H in H. Thus, the function is bijective, which implies the order of GH equals the order of H. Step 3. Cosets partition the group. Suppose there exists an element X such that X is in AH and X is in BH. Then there exists H1 and H2 in H such that X equals AH1 equals BH2. This implies A equals BH2 H1 inverse. Since H is a subgroup, H1 inverse is in H. This implies H equals H2 H1 inverse is in H. Thus, A equals BH. For any element AH prime in AH prime equals BH H prime. Since H prime is in H, AH prime is in BH. Thus, AH is a subset of BH. Since A equals BH, B equals AH inverse. For any BH prime in BH, BH prime equals AH inverse H prime. Because H inverse H prime is in H, BH prime is in AH. Thus, BH is a subset of AH. Therefore, AH equals BH. This means that two cosets are either identical or disjoint. So the cosets form a partition of G. Step 4. Count the elements of G. Let the number of distinct cosets be the following, called the index of H in G. Since G is partitioned into cosets, the order of G equals the index of H in G times the order of H. Hence, the order of H divides the order of G. So far I've shown the proof of the Lagrange's theorem. Thanks for watching. If you'd like to follow my math journey, consider subscribing to the channel. That's it for this time. I'll see you in the next video.